Hello, everyone, and welcome to our final session this year on citizen science projects. And today we are going to present to you a very novel project that has been conceived in India itself by students over here. And so I'm very happy about it because it has been conceived by students here itself. And so we have two speakers today. We have Gaurav Banerjee and we have Suman Bhattacharya. And welcome, Gaurav. Welcome, Suman. Happy birthday to Gaurav. It's Gaurav's birthday today. So
Hello, yeah,
it's
thank you,
great
thank
to
you.
be having you on your birthday with us. So Gaurav and Suman are going to talk about a project called Spectra Police, and which has been conceived by Gaurav itself. And we'll start off with a talk by Gaurav on the project, its outcome and benefits, and then this will be followed by another talk by Suman, which will be on the what's going on in the project presently, data requirements, as well as the eligibility criteria. So let me first introduce Gaurav. Gaurav is currently doing his PhD at Christ. And again, I just, yeah. So let me just mute all. Have a look at who are the participants who are. Okay, I'll just mute all. Right. So, so Gaurav is currently doing his PhD in astrophysics at Christ University, Bangalore, after completing his MPhil in astrophysics specialization from the same university. His area of research is telespectroscopy, and as a member of the Astronomical Society of India, he also has an MTech in astronomy and space engineering from Manipal University, Karnataka. Having research experience in observational stellar astronomy as well as radio astronomical instrumentation, Gaurav is also a founder member of the Calcutta Institute of Fundamental Science and Astronomy, KIFSA. Involved in astronomy popularization activities since over a decade, he has delivered over 350 popular astronomy talks across the nation. He's also the author of a book, Becoming an Astronomer, which is the first book published in India that provides details of how an Indian student can pursue an astronomy career. So welcome, Gaurav, and Gaurav will now tell us about Spectra Police.
So, good evening, everyone.
Gaurav, you can share.
Yeah, let me share my screen. Yeah, I have shared my screen. I hope I am audible to everybody.
Yeah. Please go on slides on slideshow mode.
Yes. So, hello, everyone. Good evening. First of all, I would like to thank Srishti Astronomy, OAD, SS Citizen Science Group, and all the members of these groups, especially the organizers who have organized this webinar series, which is a unique webinar series, which devotes the focus on citizen science projects which are being carried out either in India or people who are involved in citizen science projects from different parts of India. My heartiest thanks to Priya Madam and all others who are organizing such a beautiful webinar series. Based on that, I feel this kind of webinar series is the first time organized in India. So this is the date when we will be talking about one exciting project which is based on development, and everything was conceived in India, and this will deal with the spectra of stars. We basically know that stars which we can see in the sky can be different types, can be of different nature, can appear to us in different ways. So basically, if we look into this picture, which is a naked eye picture of the night sky, if you can look at this kind of sky from any rural area away from light pollution, we hope that you can see this kind of night sky, which is beautiful. Definitely, you see there are lots of stars, and one thing what is very evident from this picture is what you can actually point out is that the color of stars varies. So the natural curiosity of human beings which drove humanity and which gave birth to science, basically this birth of science has its roots, I can say, to astronomy. This natural curiosity of humanity helped them to look at the sky, to wonder with awe, what are these objects? And gradually astronomy developed, gradually science developed, technology developed. Now, We can understand by this way that astronomy or stars are very much interesting and very much connected to us. How? See, basically, apart from color, stars do have many things to tell us. The difference between this picture and the next picture, if I show, is almost hell and heaven difference. What it shows is the same picture of the night sky taken by one of the most fantastic space telescopes, which is Hubble Space Telescope. With finer details like this, the picture which is showing around more than 25,000 stars in a small patch of the night sky, what is much more evident is, yes, the sky is filled with stars, and definitely stars are of different colors. And if they are of different colors, any intelligent person, any intellectual will understand that might be these all stars are not same. They might twinkle like the same way, but they are all stars, but they might not be telling the same story to us. It is just like human beings. We all human beings are actually separate individuals. Stars are also like that. Each and every star wants to tell their story, and that story which or wants to tell about themselves, and the language through which they want to tell about themselves is actually stellar spectroscopy. So our aim for this particular interesting project will be to study the spectra of stars, the real spectra of stars, and to understand what the stars are trying to whisper to us, what they are trying to tell about their physics, chemistry, about their properties, etc. So now let me come to a very vital point. Well, spectroscopy studying of stars is continuing for years, for more than 150 years now. We know pretty well about evolution of stars, many of their properties. Then why we should go on studying stars? Is there any necessity to study stars more and more? Yes, my friends, it is extremely necessary. Why? Look at these four pictures, which actually is not at all related to stars. What it shows, four sea beaches in four corners of the world, beautiful sea beaches. Why I'm showing this picture? Basically, it is connected to stars. Why? Have you ever wondered? Yes, we all have wondered actually. How many stars are there in the universe? How many can anyone predict a quantity? How many stars are present in the universe? It's difficult to predict, but an analogy which can tell how many stars are there in the universe can be received from watching these pictures. It has been predicted, and yes, this is a scientific prediction, proper scientific prediction, the total number of sand particles which is present in the whole of Earth, whole of our Earth, wherever you go, wherever you find sand particles, the total number of sand particles present in the whole Earth is much, much less than the total number of stars present in the universe. So if this is the vastness, this is the expanse of the universe, if this many number of stars are present in the whole universe, then how much do we know about? How much do we know about the universe? Very less. And that is one primary reason we have to understand and go on studying stars. Apart from this primary reason, there is one more fundamental reason we should study stars, to understand ourselves. Why? This is the very familiar picture. Many of you who are already in high school level know about this picture, which tells you that how many elements are present in our nature. So this periodic table shows you accordingly all the elements which we have found till date, or human beings have been able to manufacture, synthesize some of the elements. Do you know, my friends, apart from the first element, hydrogen, and a portion of helium and very little amount of lithium, apart from these three, all other elements were actually produced inside stars at some distant past. So we basically are extremely connected to stars. If you see what we are made up of, if you see every matter, everything, what everything is made up of, not only in our Earth, but in the universe, you will see we are made up of elements which were either made inside the stars or during the time of Big Bang. So except hydrogen, a portion of helium, and little trace amount of lithium, everything you see Every element which we are composed of, every matter is composed of, are manufactured by stars. So basically, it is true to say that we are made of star stuffs. You can see here what is Earth's crust made up of: hydrogen 1%. You see silicon, oxygen, calcium, iron. You see the sun and stars. You see the human body: oxygen, calcium, iron. Everything, whatever you see in the universe, every matter is ultimately made up of some objects or some elements which were once synthesized inside stars. So if you people, basically maybe many of us, when we were either now also or when we were child, we have used or we have drank some of these energy drinks. So if you drink any of these, Horlicks, Complan, Boost, Bonvita, water, tea, coffee, whatever you drink, have you ever looked what is written just behind Horlicks, the nutritional facts? You see what is Horlicks made up of? See, iron, vitamin, zinc, iodine, calcium, niacin, folic acid. All these are either basic elements or are made up of basic elements. And everything was cooked inside stars. So what these companies are giving you is they are packaging it nicely and giving it to you. The basic point is, the takeaway message is what the famous astronomer Carl Sagan once said, that anybody, any child is basically a star child. Whatever we eat, whatever we drink like this, we actually drink a portion of cosmic soup. So now I feel this fundamental importance is what we should understand, that why we should study stars, not because they are huge. We should study them because we want to know them, not only because of that. We are extremely connected to stars, heavily connected to stars, to understand our own evolution, our own existence, to understand about ourselves, our origin. We have to study stars, my friends. And that is why studying stars is an important field in the field of astronomy. So if you look into not thousands of stars, if you look into only the first 25 apparently brightest stars in the night sky, definitely you will be amazed. You see there are different colors. They are of not the same color. Basically, each one of them has some difference in colors. And this color difference is something which you can notice whenever you look at the sky for stars. See, if 25 stars present such variation of colors, definitely this means something. What it means, let me give an example. Stars, or the color of stars, tells about the surface temperature of stars. And according to the color of stars, without going to details, what I will say is, stars are divided, stars have been classified according to their spectral properties, based on their color, based on their spectral properties. And more than 99% of the stars which you see in the universe will fall in these 7 categories: O, B, A, F, G, K, M. The basic difference, what it tells is, the O-type stars are the hottest. They are extremely blue. And these are some of the examples of those kind of stars. Basically, all of them are visible in the winter sky. Winter is coming with naked eyes. So that's why I have shown these examples. So go on like this. You see our own sun. Sun is a type G star, G-type star. What is its surface temperature? Around 6,000 degrees Celsius or Kelvin. M-type stars, you see, when you see a red color star, you can understand readily that the surface temperature of that star is like this, somewhere nearby 3,000 Kelvin. So the surface temperature of the star can be readily understood by looking at the star or by understanding what spectral type they are. So now comes the spectra and the spectral type. Well, yes, it is true that if it's a bit difficult to remember this sequence, there is a fantastic mnemonic. That mnemonic has not been prepared by me. It's a 100-year-old, maybe more than 100-year-old mnemonic. Oh, be a fine girl or guy, kiss me. You see, the first letters of this sentence tells about the spectral type. So now I'm coming into the spectral type. Basically, stars are divided into majorly 7 types of stars according to their spectra. And our project comes from here. What is a spectra? How a spectra is formed? In a very short note, spectra can be of 3 types. How spectra can be formed? What type of spectra? Three types of spectra can be formed, which are governed by something known as laws, Kirchhoff's laws. Gustav Kirchhoff, who explained how spectra can be formed. You see the first case, what happens is, if suppose light or radiation, which is radiating or which is originated from a source, if that light passes through a spectroscope or a prism, and you want to project that projected or that light which is, or the radiation which is coming out from the prism or the spectroscope in a screen, if you want to project, you will see that naturally light has been divided into its 7 component colors. That is the continuous spectrum. But something else can happen. If suppose, this is the first law, how a continuous spectrum can be produced, and there are 2 other laws, how emission and absorption line spectrum can be produced. In case of a star, what happens is usually like this, the third law. What happens is, if suppose the light or radiation which is originated from a source, after originating from here, if that light or radiation passes through a cooler gaseous region, and after that it passes through a spectroscope, then you will see a spectra like this, a continuous spectrum, and on the top of that continuous spectrum there are lines like this, black color lines. What it tells is, each black color line will be formed in a particular wavelength, and that will tell us the proper signature, what elements at what quantities are present in that cooler gas which is surrounding the source, which is surrounding the light source. This is what happens in a star. Opposite happens in case of an emission line spectra. So this is what happens in a star. Why? You see, if considering, now you consider this as a sun, our own star. So basically what happens, light or radiation is generated at the center of sun, very hot. After that, it is passing through the outer layers or the outer gaseous layers of sun, which acts like cold gas, cooler gas, and after that it is coming to us. For every star this happens. So whenever you see the spectra of a star, we usually, any star shows you absorption spectra. And studying these absorption lines, you can understand about the physics of stars, what elements are present, how much quantity it is present. You can understand, you can read the properties of stars by watching or reading or understanding the spectrum of the stars. Now, nature is always a fascinating place, my friends. Nature has always given us surprises. What happens is, we see something ulta, opposite also. There are few stars which shows us opposite, emission lines instead of absorption lines. And that is very fantastic. These are basically known as emission line stars. So you see here, this is an emission line, not an absorption line like this one or black one. So our work or the project which we are discussing today is based on understanding and studying those rare category of stars which are known as emission line stars. There are several types of emission line stars like what you see here, B star, Hardwick, T Tauri, several types. No need to go to the details. The basic fact is, why such emission lines are produced. We know pretty well that any emission line star like this, they are surrounded by a circumstellar disk, and that disk might be gaseous, and inside that gaseous disk there might be dust also. So by studying the emission lines of these emission line stars, we can understand disks of the circumstellar disks of these stars and how the star itself behaves, the property of the star itself. So emission line star studies provide us the best natural laboratory to study stellar disks, to study stellar disk physics. And that is why understanding and studying these kind of stars is important. That is why we have nowadays lots of data coming. We have a huge amount of data in different places, archive also, where data is there, but persons, astronomers, is the number of astronomers is less. And this actually motivated us to start a new project where citizen scientists can come and start contributing in stellar spectroscopy research. I would like to stop my portion here because my colleague is also there who is working with me at the same university. And I would like to suggest that my colleague Suman Bhattacharya He can take over from here. He is an expert in stellar spectroscopy and obviously the instrumentation. He will be giving you the details that after understanding what is stars and why this project is important, let's now get to the details what the project is about, what we are going to do. My friend Suman, I feel you can hear me. You can now continue from this portion.
Thanks a lot, Gaurav. Thank you. And welcome, Suman. I'll just give a short introduction to Suman. So, Suman, who's now going to tell us about details about the project, is doing his PhD in astrophysics at Christ University, Bangalore, after finishing his MPhil in astrophysics specialization in the same university. And he's recently identified a rare class of new category of stars at a rare phase of transition with the assistance of a team of Indian astronomers. Apart from research, Suman is also involved in astronomy popularization activities for the past 5 years, and he's been involved in Spectra Police since its inception alongside Gaurav. So I welcome Suman to tell us about Spectra Police.
Yeah. Thank you, Gaurav, and thank you, madam. Okay, I'll just share my screen first. I hope the screen is visible, right?
Yep, all's good. Good.
Yeah.
When you put it on slideshow mode.
Yes. Okay. Yes. Yeah. So I'd like to special thanks to Priya Hassan madam for arranging such a nice webinar, so that I'm really glad that through this kind of webinars, people now can interact with us, and also we can interact with lots of people who are actually intended to work in astronomy, but maybe many of them not able to get that much of information, like what is going on in a serious manner. So I think this kind of programs is like a backbone of backbone to build a good future in astronomy as well. So okay, so I'll continue. As Gaurav has already mentioned, there are lots of databases which are actually collecting data for this kind of stars. So first, going inside that star, I just want to give you a little bit of glimpse of about those specific type of stars. I'm going a bit specific about this thing. Okay, so you can see in this slide that we are talking about Gamma Cas. It's a Gamma Cassiopeia. It's a star. You can see this star in the slide like this. This is the Gamma Cassiopeia. Now, what is the importance of this star is that this is the first identified star, which is a category which created that new category in stellar astrophysics, which is the emission line star. Now, why is this star is so important in this study? Because as Gaurav already told that normal stars shows the absorption lines. Okay. Now this star is showing emission line. So it's not like showing that material, which is absorbing light, but it's now producing light in some certain wavelengths. Now you can see in this slide that this is a example. This is an example spectra of of a Gamma Cassiopeia. You can see there are lots of bumps. Okay. Now this bumps actually the emissions. Okay, emission line in Gamma Cassiopeia. So this is also this is the part where our study is actually situated. Now, why this specifically? This is okay. We understand that this is the first star which actually started the study in emission line star category. Then why this study is so much important in stellar astrophysics in whole in general is that this star actually started the actual spectroscopic analysis of stars. Now you can see in this paper, this is a paper from 1866. This is a picture of Father Angelo Secchi, who first observed the Gamma Cassiopeia and observed those emission lines. And this is where a proper spectroscopic analysis started. Before that, it is observed, it is analyzed, but a thorough analysis started from this specific star and specifically from this paper by Father Angelo Secchi. Okay, yeah. So before going a little bit further, we want to show you like the Indian facilities where this spectroscopic, I mean, where we took this spectra from. Okay, in this two pictures we can see in the in this picture. This is the this one is the Hanle, Ladakh. This is the this is the Kavalur picture. This is the VBO. This is a two-meter class telescope, and this is also this is the Hanle. I mean, from in Ladakh. So this is the telescope facilities we are having in India. This telescope takes from medium to high resolution spectra. We are actually collecting data from this telescope, and we are actually sending this data. We are actually taking this data for our analysis. Now, all the students like who are actually interested in this Spectra Police project, you have to understand one thing. We are actually taking this serious spectra for our project. Okay, so you can understand that this is not a demo thing. So we are really trying to make you understand that this is a very serious project about the stellar spectroscopy, because by this we are actually directly communicating with the star, because as you know, spectra is a language of star, so that we can go inside the star, we can understand the star, what that star is actually made of. Okay, and if we know about what is the star is made of, we can indirectly also know about what we are actually made of. So this is a long way to go. Now, this is an actual spectra in the current time. This spectra is taken like in the Banerjee et al. 2021. Now, this taken by like a CCD. I mean, there was a telescope. Then that telescope, through the telescope, we recorded the spectra, and this is the output. This is a modern output of a spectra. We are not going into detail at this moment, but you can see these bumps again, upward bumps, and that are the emission lines in a spectra. Now, why? Why we are actually, I mean, why we suddenly thought about this? Okay, let's start a project on stellar spectroscopy, where we can actually involve people, involve students who are interested, obviously. Will do some work on the spectroscopy. I mean, why? As Gaurav already mentioned, like already he shown one slide where he have mentioned about BESS website. There are lots of data. That's right. But that data is also nothing to what is coming up at this time. If there is some kind of computer programming, whatever it is, like which can actually study a spectra or a language of star, I mean, that is fine. But you have to understand that human observation, I mean, there is nothing which is near to the human observation, because human have that power to understand, to search, to find out, to extract out, to detect out that hidden features, hidden story. To a computer, to a machine, maybe those features will be look like same. I mean, they are all same, but a human can understand what is that smallest, that tiniest changes there, and that change could be a revolutionary change in the star, or could be a revolutionary feature which no one knows till now. Now, again, like, why we should start it now, or why we like, yeah, let's complete our study, then we can start this Spectra Police project, that will be also good. But why we started now? Because I want to show you this picture. You can see this is a very normal like a spectrograph. Like, this is the prism, this is a two telescopes, small telescopes, then this is like a burner. It will can study the elements inside that burner, and I mean, this is a one type of spectrograph. Now, this was something like around like a 200-year old. This is around 1860, sorry, not 200, it is a 150-year old. Now, after 150 years, right now, the spectrograph, which is used in a telescope, is look like this. Okay, so you can see, and by the way, this is a picture of like, this picture is from like 2008. I'm not, I don't have a picture of like 2018. They have upgraded this machine. Now, you can understand that what kind of improvement happened right now. Now, at this telescope, people can observe, I mean, scientists or astronomers can observe at least something like a 1,000 times more stars at the same in one night than that kind of that previous spectrograph, I mean, which I showed you, because that kind of small instrument have its own limitation. Now you have to understand that a flood of data is coming, flood of data. and we have no power to handle that. I mean, yeah, telescope observed the sky, it took the data, then what? Then what we are going to do about it? I mean, are we going to just sit there and like waiting for some people will come up? No, we have to make people understand, make people know that we have to do it. We are that upcoming generation. Okay, so that's why we come up with with this project, so that people understand that yes, spectroscopic study is a very important part, and if they know about it, they will understand that what is the importance of this like this kind of to understand this, like this is the future. I mean, this is the main part where we can actually interact with star in a more precise way. So this is like a modern system. Now I would like to say a little bit about this telescope, LSST. Now this is a telescope which I just told you, like a huge flood of data is coming. Okay, I'm not talking about other upcoming other telescopes, just one out of them. I mean, just talking about one telescope, LSST. This telescope alone will generate 15 terabytes of data per night. Your laptop is having 1 terabyte hard disk. Now just imagine this telescope will generate 15 laptop worth data in one night, and they're going to store it. That's all. I mean, who is going to study that? Yeah, they will generate some kind of computer language, computer vision. That computer vision will see the spectra and generate something, some data. But those data, you have to understand, those data will be never accurate with respect to a person. Okay, and you guys are the person who actually going to see that spectra, understand the language, and that is where our this project resides. So I want we want to make you understand that yes, you are the future. And by the way, that future is very nearby. This telescope will be start observing around end of 2023, and this is 2021, and almost its end. 2022 is next. So you can understand that the upcoming future thing is already now happening. So we should go ahead to the next step of amateur astronomy. I mean, that is fine, amateur astronomy, but no one told you that, yeah, in amateur astronomy, you cannot do a professional work. That's why in this project, we are going to implement, we are going to use professional output from the professional telescopes and going to provide those spectra to the students directly and train them to understand that actual spectra, what is happening with the actual spectra. And we are also going to take the output from them for our next steps of research. Now let's come to the Spectra Police. As I just told you, like what is the motto? Why we suddenly started it? Because I think sometimes we started it, that is fine, but we are still, came a bit late, because like as I told you that this only one telescope is coming on like end of 2023, and it will generate 15 terabytes of data per night. Okay, so I think something, I mean, we have at least started it right now. I think we hopefully think like people will get some idea, get a level of idea, professional level of idea, where they can actually implement and understanding into the into the actual study, actual help. Because when they will release the data, our trained people can immediately understand and maybe can start analyzing those data without getting any kind of like serious issues, I think. Okay, so what is Spectra Police? So obviously we are trying to understand the emission lines in a star. Okay, as you can see, I have already have Gaurav mentioned that emission lines are those brighter lines in the spectra, or the strip of this kind of colorful band. Okay, now those some lines will be brighter in those bands. So those are actually emission lines. So our team, this is our team. Project in charge is Gaurav Banerjee. Project coordinator is me, Shuman Bhattacharya. And data cross-checking will be like done by expert reviewers. And like team leader and team, I mean, there will be two team leaders. One will be for data compilation, when like data compilation will be the step where we are actually started providing the actual spectra. And there will be literature survey. I mean, we are not going to, just take random stars. Obviously, we need to know about the stars if those stars has been already studied in the past. So we need to know that also. And obviously, thanks to KIFSA, our collaborator. Okay, then in the next slide. Yeah, I think Gaurav, you can you can take over from here. I think Gaurav will explain about the guidance of the research. I mean, what we are going to. I mean, the students who are actually interested to participate in this project. So they need some little bit of like previous knowledge or some kind of level of basic school education. So I think Gaurav will take over from here. Hello, Gaurav, can you hear me?
Yes.
Yes, yes. I'll stop sharing. You can share your screen now.
Yeah, sure.
Thank you.
Right. So let me just take another 5 minutes to tell what we are going to do and how we are going to do this. I feel I'm again audible. So as my colleague Suman has already mentioned that we will be studying a particular set of well-known stars where spectra is available, real spectra, and obviously it's an exciting work where people will be able to, or citizen scientists will be able to contribute in real research. But yes, as it is a real research case, so there is a basic eligibility. You have to be at least in 10th standard or 10th standard pass. Obviously with science, you have to love astronomy, the subject you have to love. You have to understand that astronomy is not only watching the night sky or not only we're taking pictures, and that is not only astronomy, that is also a fascinating part, but you have to love the subject. You have to know something about astronomy. At least 4 to 5 hours a week of dedicated time is required from all of you, anyone who is ready to participate. We don't need any other qualification, we don't need any other certificate, we don't need any other kind of eligibility scheme apart from these two basic cases. One is love for astronomy, and one is at least we want you to remain committed to this project for 4 to 5 hours a week. And what we will provide, how will you start the project? Everything we will be providing. We will be giving a coursework or giving the guidance. This coursework will consist of 6 classes. Also, apart from that, there will be practical demonstration, practice, direct practice to how to see how to handle the spectra, how a spectra looks like, how to identify spectral lines, everything. And the basic coursework of 6 classes is containing the basic facts about or basic idea about spectroscopy, stellar spectroscopy, what they are about, what kind of stars we will be studying. All these things will be covered. Don't have to worry about anything that you have to buy something new, not at all. If you have a desktop or laptop, which you all have nowadays, you have internet facility and Microsoft Office. So that is enough. That much is enough. And your happiness and your love is enough so that you can become a member and participate in this project. And any study material, any video of the classes, everything will be provided. You can go on revising. Any one of you, if you want to join the project, there is one way is you can send your details mentioning about which class you are, where do you belong from, which institute, which place, what is your age, and why do you want to join this project, maybe 1 or 2 lines. You can send a mail to this particular Gmail ID, and that is enough. Anyone who is satisfying the basic eligibility will be taken for participation. So presently, I would like to say is the coursework has already started. 2 classes are already over. The 3rd class, which will be taken by Suman, is scheduled for tomorrow. So out of 6 classes, well, if 3 classes are over or 4 classes are over, nothing to worry about, as all classes are recorded, and everybody who is a participant of this project will get the detailed videos of all these classes. Whenever we get a proper time, we will send the videos. Presently, we are having over 50 participants in this prestigious project. And from 13 states of India, there are over 40. Among 50 people, there are over 40 students. That is something which are exciting us. That is something which we liked. From 13 states, we have a participation. Also, we have participation from outside India, also from UK. So we wish that this number of participants will increase more, and we all will join our hands together to understand, to study the spectra, to read the language of stars. what is the outcome? What we will get after doing this? Definitely, as a citizen scientist, basically citizen scientists who do contribute in different kinds of projects, they do it because of their own pleasure, because of their own satisfaction. Obviously, you will get 100% pleasure from this project as it is dealing with real spectra, real data. Satisfaction will be a bit different level because this satisfaction as a kind of satisfaction where you will be contributing to real research. Obviously, that you will get. But apart from that, if someone is providing significant amount of contribution, obviously what is significant, that will be judged by a proper reviewer team, expert reviewer team. So that will be judged, and if suppose somebody's contribution is judged as significant, then when a research paper, if it is coming out after doing research on this data, acknowledgement, proper acknowledgement in the research paper will be produced, given to that particular person or people, whoever is the citizen scientist. And yes, definitely, if there is substantial contribution somebody is giving, then we do not mind to give even the co-authorship of a research paper, which will be published in a proper journal, peer-reviewed journal. So yes, but my friends, you have to understand, for getting acknowledgement in a research paper and for getting co-authorship, that is, you have to give significant or really, really good contribution. Really, you have to be, you yourself have to tell yourself that, yes, I am not getting the co-authorship or acknowledgement because of, I say, just I know these people, that's why they have given me co-authorship. Not because of that. You yourself will be satisfied. And if these things you can get, any one of you, then I can bet that in future, if you want to become an astronomer, these things will really help you. Real knowledge, how to do research, real understanding what is stellar spectra, spectroscopy, these things will definitely give you help. And if you can become a co-author or an acknowledged person in a research paper, definitely it will give you help in your career also. So basically, if you become an astronomer in future, as Suman has already shown, just give you a bit more glimpse, these are the places, actual places where an observational astronomer actually works, like us. So we work in maximum places like this. So basically, the first two pictures is of Nainital, Uttarakhand. Nainital is a very beautiful city, but the place where astronomers work is this one. You see how dark it is. It's actually the Aries Institute in Nainital. This third one is actually the real telescope through which we work in Kavalur. So you see, it's dark place. This is the real control center of the telescope, which is controlled remotely from near Bangalore, Hoskote, and the telescope is Hanley, the 2-meter telescope, Himalayan Chandra telescope, which is situated at Hanley, which is remotely controlled from this control center. So this is the real office where an observational astronomer works. Either you can become a good faculty of a university, or you can work as an astronomer in a proper research institute, or both. You can do both also. But please try to remember that real astronomy deals with real data. It is not only watching the night sky and taking the pictures. Real astronomy is much, much more exciting and much, much more fascinating than that. If you love the subject, if you realize the subject properly, this is the computer screen, this same computer screen. You see the real two stars. It was an observation of a binary star was going on. So you can understand that this is important. And this will be the real office where you can work. You can get the flavor of astronomy if you are a member of this project gradually. I would be now happy to announce that one institute, one organization which Suman has already mentioned, Kolkata Institute of Fundamental Science and Astronomy. This organization, whose motto, whose objective is to popularize astronomy and science among school students in Calcutta and nearby places, they have officially collaborated with us for this particular project. They will be providing us the support and everything. If you go to this particular website, you can find the details of this particular project. The website is also going on in more and more refining, but the project details you can find here. You can go to the project, you can go to the KIFSA website also and go to the contact section and send your details if you want to join this particular project. So anyway, you can do that. And it is our happy moment for us. We already have Mr. Pratap Pal, who is the chairman of this KIFSA organization. He is also present today in this webinar series. Well, I would like to just for maybe 2-3 minutes, I would like to request Mr. Pratap Pal if you can just tell something about KIFSA and if you can say something. It's an honor that this institute has made official collaboration with us now. Am I audible? Yeah, Pratap Pal.
Yeah. Am I audible, Gaurav?
Yes, you are audible. Yes, true.
Okay. Thank you, Dr. Priya Hassan, Srishti Astronomy and AstroSpring, for organizing this beautiful webinar series. Thanks to Mr. Shobhan Acharya, founder of the SA South Citizen Science Group. And obviously, my special thanks to Gaurav Banerjee, Shuman Bhattacharya. I will take a very few moments to share my feelings actually for the participants. When Gaurav was talking about this project, I remembered one name, that is our very own Radha Govindra Chandra. He was basically an amateur astronomer. And if you go through the biography of Radha Govinda Chandra, those who are amateur participants here are going to participate in this project can easily understand that what an amateur astronomer can do actually. When Gaurav approached me with this project, frankly speaking, I was really charmed. And it is a very, very ambitious project indeed. But I have strong belief that Gaurav and Shuman, they are so passionate about astronomy. I know them personally. Without a passion in this very young age, a person like Gaurav can't do this. Gaurav already authored a beautiful book, Becoming an Astronomer. I have gone through that book also. And he is really dedicated to popularize astronomy. Our KIFSA, Kolkata Institute of Fundamental Science and Astronomy, if I talk a few words about it, this is a very small organization, no doubt, with very little resources. But this organization is dedicated to popularize basic sciences, mathematics, and obviously astronomy among the school students and general public. We are working seriously with that, and we have very little resource. And I offer this Spectra Police project participants, if they like, they can also use the resources of KIFSA also. KIFSA is a beautiful library of popular science books, popular astronomy books, and some things like telescopes, etc. Whatever they need, they can take a free access of it. I promise it. And we may also consider to give them a certificate if they complete this project successfully. And I believe each and every participant of this Spectra Police project, with the able leadership of Mr. Gaurav Banerjee and Mr. Shuman Bhattacharya, each and everyone will sincerely work. My best wishes to all of them, and to all other members of this Spectra Police project, Mr. Pallav Roy Gupta, Mr. Arindam Pramanik, Mr. Shobhan Acharya. My many thanks to them for taking such initiative, such an ambitious initiative. But I'm sure that there is success is waiting for us. Thank you. Thank you once again to everyone.
Yeah, thank you, Mr. Pal, Mr. Pratap Pal. So it's nice to hear that. Well, I and Suman, I guess we also didn't know that the institute is already trying to offer certificates to the participants. This was also not known to us till now. It's a marvelous opportunity. So nice that KIFSA is also offering their resources. If anyone wants, they can use their resources. And yes, in that case, in the outcome case, we will be adding next time when we give the details about this project to any other webinar. Then yes, if anyone or if everyone can do up to a certain level of contribution, they will receive participation or might be appreciation certificate from KIFSA, which is an institute. So that is something which was new to us also. So it's a happy moment for us. Thank you, Mr. Pal. Thank you to KIFSA. Thank you to the whole team for organizing this particular webinar series. I would like to go back to my colleague Suman. We are at the end of our talk today. We will be opening shortly for taking questions. So Suman, it will be good if you can conclude on behalf of Spectra Police project. Thank you everyone for listening.
Yeah. Thank you, Gaurav. Thank you, Gaurav. Okay. I'll share my screen now. Yeah. So before concluding this today's talk, I want to show you some of like what we have done till now. So I just wanted to show you some of our previous work which we have been published. Sorry, I shared the whole screen. Yeah. So what we have done till now, based on this emission line star, about their rotation, about their physical dynamics, about their surrounding, about their environment, about their companionship. So about on those topics, we have been going on studying. Okay, and based on, obviously those data we have been taken from like multiple telescopes, and we have already we have been collaborated by like 20 plus facilities all around the world for that. But we still have lots of data, which is which is just sitting there to get revealed more information, more shocking things about those stars. So I'll just go through, I mean, briefly about this. This is the this is the first paper is published by Gaurav himself. It's on like optical spectroscopy, and I mean Gaurav Banerjee and the team from Christ University. This is the like classical B star galactic, which emission line star, specific B type emission line star situated in our galaxy itself only. So this is one of the that work. Then a very nice article written by Gaurav, which is about the like understanding or the general idea about B star. What is the B star? The first one is a bit more like a professional range, but to understand that, I think you should like study. You can just search it, B star colon messengers of stellar disk physics, because this emission line is actually generated from the disk around the star. So that's why the environment is also important for that to study about a star. Now also there is other classes of emission line star. This is the identification of another, I mean another like a low temperature emission line star, which is done by another one of our colleagues. This data also situated in our galaxy itself. Now there is another work which is the new category. This is actually a new category of star, which done for with the same team, help of the same team. This work has been studying the evolution, that how that disk is evolving and what will happen after a certain time. In this case, that certain time is in millions. That what will happen about the star, what will change happen in the star after certain million years. So the evolution of the star we will understand. Now, other than this, we have more two works which has been just published. One is the very older stars, like these stars, emission line star, but they are very old. And also like one is upcoming. Like this is also like the change about the disk of the star. I mean, you can understand maybe some points are like going I mean, little bit confusing, but this confusion, I mean, you will feel happy because when you get the answers for this confusion through spectroscopy, without we were not going to give you like a written explanation of this. When you understand the spectra, you will understand all these things instantly. So thank you for this for joining us. I think I should like ask Priya Hassan madam to take over. I mean, should I stop presenting now? Hello, madam.
Yeah. Thanks, Sumant.
Yeah.
Thanks,
Thank you,
Sumant.
madam. Thank you,
Yeah.
madam.
So in short, you will show people the step-by-step procedure for spectroscopy, or in the tutorials, right, which you all are running?
Yes.
Okay.
We
So people who want to join will have to watch the tutorials that have already taken place so that they can then start working on what is, right?
yes. We are recording our classes for
And could
that.
you all please cut paste the website where you have everything? So
Yeah,
that,
sure.
because you have a website, right? So
Yes.
that will have links to the tutorials as well as the videos and all which are there, right?
Yes. We will upload that on the website also.
Okay. And let's start taking a few questions. There are a few questions here already. So one is by GB Raghav Krishna. He says he's a second year BSc physics student and he's been involved with Rad at Home, etc. So he has some experience with galactic spectroscopy. So will it help in stellar spectroscopy is question number one. And question number two is the data which you'll be doing, is it only in optical or are you going to do with gamma ray, X-ray, ultraviolet, etc.?
Yeah. It's a nice question. Yeah. So it will be optical, basically, my friend. It will be optical because optical spectroscopy is something which you can do up to a certain level in an easy manner. When it comes to gamma or some X-ray or infrared, that becomes a bit more critical, complex. So we will be dealing with optical spectra, optical wavelength spectra, and obviously, yeah, it's GB Raghav. So any knowledge, if you have any knowledge regarding spectroscopy, regarding astronomy, physics, that will be definitely helpful. It will help you definitely. Yes. It will be help you. You already have some idea about spectra of galaxies. That will be definitely helpful. The technique might be the same, but understanding of physics will be different. That's all. Definitely. Welcome.
Yeah. Thanks, Gaurav. And then there's a suggestion by Bonnie Ferber where she says in Space Edge Academy, they have a few courses about spectroscopy. They're free. You're welcome to go through it and you can read through them with no account. You sign up for an account and you can participate in the quizzes in the survey if you'd like. And you can use that other than the material that Gaurav and Suman are sharing in their sessions. You could also go through this. The website is also mentioned over here, Spectra Police, KIFSA.in. So that would also be a good reference point.
That
So
would be
what
great.
do students do if they want to join you? They should send you all emails, or how should they join the whole thing?
At this moment, we are just like only through email. Like they have all they need to do is that about their educational background, and like we are already Gaurav told about that class 10 minimum, and why they wanted to do this. I mean
So
their
they should send you an
motivation.
email.
Yes,
They should send you an email.
email. Yes, that's all. I already posted the email here. I will write it again here.
Yeah, okay.
One
spectrapolice@gmail.com.
Yes.
one email is enough. Yeah.
Okay.
Definitely. And thank you, Dhurva Bonnie madam. So it's nice. It's a wonderful resource, I feel. Yeah, thank you, Bonnie madam.
Yeah.
So anyone can go through that
the
also.
link has been given so people can go through it and see if they would like to give them feedback about the whole thing. So
Thank you, Bonnie madam. I mean, this will be really nice. Yes.
Yeah, I can see the website over here. Let me share. I can show it to everybody.
Yes,
Here's the website that Bonnie ma'am is talking about, Space Edge, where you can see here's the part on spectroscopy written by this thing that it covers high school students. And you can see there are quizzes, etc. There's a lot of material available over here. On the left, you can see more stuff. And this would be a good thing, a good resource to add on to what is being done by Gaurav and Suman, right? So
really, it is excellent. We would recommend that everyone should go through this. It's excellently written.
Yes.
Nice.
I mean.
Yeah.
So please have
Thank
a
you,
look.
Bodhi madam, for sharing
Thank you.
such a
Yeah,
nice,
thank you. Thank you.
nice
Yeah.
resource. Yes.
Yeah, thanks. So I will stop the share. And there's some other question. Okay, so I don't see any more. Okay. Yeah. So, okay, so this is by Kiran Mehta. Does the hotter corona of our sun or a star not cause emission lines?
Yeah, this is nice question. Definitely. So, no, my friend, hotter corona will not produce a stellar spectrum. Basically, corona is actually
Your
so
audio
solar.
seems,
Yeah. Now it's okay. So solar corona, which is away from the solar photosphere, that is very tenuous. It is hot. It is true. It is hotter, but it's very tenuous, very thin. So from that, you will not get an emission line spectra or spectra. Basically, to study the corona, you need to do something else. Obviously, I can see that after Kiran, somebody else like Akhan has also asked a question like
yeah.
that. Between any star and telescope, there might be clouds of gas and dust. Yes, this is known as interstellar gas, interstellar medium, or interstellar dust. So that is also very tenuous. That is also very tenuous, very thin. For that, it basically it will not produce a separate spectra, but it hampers spectra. That is true. It hampers spectra. What we have to do is we have to do some kind of corrections so that we can avoid this kind of interstellar effects which we do is something known as interstellar extinction correction that is has to be done. But yes, these interstellar gas and dust which are very tenuous, they do not produce a separate spectra. To study them, if we want to know about them, yes, to study interstellar gas and spectra, there is a separate field which is known as polarimetry. So with polarimetric technique, you can study interstellar gas and dust particles. You can study that. So yes, this is true. It's a nice question. Thank you for this.
Joyshri
Thank you. Yeah.
Silas, I already answered it. The question was, is participation and learning free? Yes, it is. Right. So, there, right? No charges, obviously.
Yes.
Yes,
I
yes,
mean,
it's
some
free.
yes. I mean, this is also free. I mean, also like the schedule. I mean, please send us the email like with your information. So, one student, Sumit, who is like from class 6. I would suggest you send your mail with your motivation. I mean, then we will see. I mean, we are not going to reject anyone. Okay. So I would suggest to read your motivation because like I want to see you there, but you have to do some work for that. Okay. So I think you send us one mail. Okay, then we'll see. Okay, Sumit.
I think you can see Himadri's question also.
Yes. Yes,
Provide
yes,
me
just
the
now.
info requiring the schedule of the tutorial classes.
Yes.
I think it's on the
Actually,
website, right? Or
yes,
yeah.
yes. We are not going to like update it in our website because like we are like a bit busy with our own work as well on the parallelly. So we are a little bit like we may change our schedule. So please send us one email and then we'll join you with our WhatsApp group. And in the WhatsApp group, we are constantly updating about like our next class and what we are going to do about next class and those things. Okay.
Yeah. Okay, so Sumit says she's going to work hard. So fine, that's fine, no
Yes,
problem.
yes.
Yeah. Everybody is
That's
welcome,
good.
don't worry. You can definitely join.
Absolutely.
Are there any more questions? Please post it on chat or I don't see any more questions on chat.
Okay, no more questions.
So that what you know is, I mean, you know how to go ahead, send a mail, and you can join the WhatsApp group. So I'll send the mail now, and that would put you with it. Yeah.
Okay,
Any
there is
closing
a
remarks from you all,
yes, yes.
Suman or Gaurav? Any closing remarks?
I think we have like
Yeah.
yeah, go yeah.
So hello everyone. Yeah, it was nice. Yeah, it was nice to hear from all of you. And yes, it was nice that I feel many of you are interested to join. So yes, you can join. You can join and let us join hands and study the stars, read their language together.
Yeah.
Thank you, everyone. Thank you.
So thanks everyone. See you. Happy New Year to everyone. Merry Christmas and Happy New Year. And we hope to be meeting you all once again next year. with some
Happy
more
New Year.
interesting
Happy New Year
work.
to you also, Priya madam.
So Happy
Happy
New
New
Year
Year.
to
Merry
everybody,
Christmas.
and let's
Happy
meet
New Year to
next year,
everyone.
hoping for a better year coming up.
Thank you.
Bye bye.
Thank you.